I'm Brian DeLuca, and I am here with Manny Chavez at the X-Peria booth at APEC 2025, and he's going to show us one of the demos they have.
Sounds great. Thanks a lot, Brian. I appreciate y'all stopping by. The demo that we have here showcases Nexperia's first isolation products, and we're really excited about these because they have both a signal and a power isolation path. In order to have a fully isolated system, you need to have both signal and power isolation to protect your components or protect the people who might be using the circuit. If you don't have one, you could be bypassing your isolation barrier, and that could put equipment in a costly repair situation, or you could put people in a dangerous situation. What we have in this demo is a scalable model of an EV where you might have high voltages present due to EV charging or battery charging. Right here it's just 120 volts, but in an EV it could be 240 if it's connected to AC mains, or it could be even higher voltages at DC. Inside of an electric vehicle, you can have higher battery pack voltages. We're talking 400 or 800 volts, and they're getting higher every year. However, even though you have these high voltages present, you still have some sensitive equipment on the car. You have your microcontrollers, you have zonal controls, and then additionally you also have user inputs. All of these need to be protected in case there's a fault or in case there's any sort of noise from the high voltage switching that happens inside of an EV. And in order to protect that, protect those devices, you have isolation in between. So those are the devices that we're looking at just up here on the X board in the middle of the demo. We have the isolation transformer driver, NXF6501. That's Nexperia's first push-pull isolation transformer driver. And this is used to generate a 6-watt isolated power supply, which is plenty to drive isolated gate drive bias supplies. It can drive control circuitry or sense circuitry. And right here, we just have about a 150 milliamp load, but we can drive 10 or 20 of these because the driver can provide up to 6 watts.
So what's one of the things engineers need to think about when they're designing this into a system?
When they're designing isolation to a system, one of the first concerns they might have is creepage and clearance. Depending on what kind of voltages you're trying to protect from, you might need higher physical distances in your PCB to make sure there's no arcing around the package. Nexperia's isolators are rated for 1.5 kV for their entire life. That's up to 30 years. But based on the package, we can go up or we can go down from there too.
Do you want to show us how this demo works?
I would be glad to. So just to show off the signals that are isolated here, we can turn the truck on, and that sends a GPIO signal through the controller here, through the digital isolator, and into the rest of the truck. We have controls for the lights. You can see the headlights turn on and off. We also have PWM signals for the steering wheels and for the throttle sound as well. And then if you grab that ping pong paddle and hold it in front of the truck, you can do like a back and forth. This is kind of like a parking sensor or like a collision detection. So we have an SPI right here, we have GPIO signals from the buttons, and then we have PWM signals from the steering and the throttle. So all of those types of digital signals can be isolated using the digital isolator here.
Awesome. Well, Manny, thank you. Thank you for sharing with me today.
Yeah, thanks a lot, Brian. Appreciate your time.